Hello again, I'm here with Viktor Winschel from Oicos, and he's going to show us how Oikos software works.
Yeah,
thanks.
Yeah, so this is a very first prototype. The goal of this prototype was to set up the infrastructure and also to go through a first example economic model or game and get a feel for what the workflow of modeling with string diagrams games could look like. And this implies that we had a very dumb user interface. So the creator was no intelligence to the user interface, just enable the very basic operations, and we as the user would just think about how then any kind of intelligence would look like. So intelligence means syntactic sugar or automatic layout of the nodes and all this stuff. So that means it is not really, it is very difficult to construct a really model. So I will come back in the second part a little bit on the infrastructure, so how the whole cloud system and so on looks like. Here you see the user interface. So we have canvases, which is where you put your string diagrams on. That is one canvas with another tab. I will go to a predefined model. Then here, what you do here is you really construct the string diagram. So you create here one node, create another node, and then you take here, create an arrow here, and then connect it. So it takes time, and it's really not user friendly here. But as I said, that was the very first thing. We wanted to get the whole thing running, and this little user interface, not little, but it's big deal and big work for, I guess, to get it really right, as Jelle said. So, but that was not really the concern here. Maybe a short hint about these spaghetti code kind of things. Our approach to that is boxing. That's how we code it. So you select here a bunch of nodes and then create here a box. You see what happens here? So the whole thing here gets replaced with the internal structure, which is then here. And then, you see the internal of the string diagram here has connection to the canvas ports.
So I see the fundamental problem with these string diagrams. You're going from top to bottom instead of left to right.
Yeah, we wanted
to.
We wanted to add that as well, but yeah. So that's the thing here. So that's the boxing thing. Jules always then cries out. This is no semantics, but it's very practical. I think one need to think about it in a fun way possibly.
Semantics now, something operates.
Yeah, exactly. So then that's next steps. However, so that's this thing. The overall user interface looks like that. So we have here. Oops. So we have here the canvas itself for the string diagrams. We have here the inspector for all kinds of properties of these string parts and wires and so on for the labels. We have here the GHCI itself, and here we have some plotting stuff going on. So this is the very basic things. You see there's no structure, so I just bumped out here to see how it works. Then an actual game would look like that. You see there's also here not really oops, sorry. Yeah, my this was my yeah, something like that. So what's going on here? So this is a model of a battery. So a battery, so time goes up, top down. A battery is is what is a battery doing? That's a basic building block for energy networks. So there is a price going on for energy, there's demand going on for energy, and the battery optimally decides whether to fuel the battery, so buy energy from the outside, put it into the battery, and then sell or sell the energy from the battery back. So that's the situation. It's an optimal decision. It's not really a game, so it's even simpler than a game. It's a one person or one battery decision, but it's over time. So it's an infinite horizon model. So that's so each point in time the battery decides to fuel or not to fuel. It's a saving. So economically it's a saving model, right? Applied to batteries. So the saving model is either you consume from your tree which produces whatever, or you save it and so on. Alright, so that's how it works. So the looks like that. So we have here the charge. So there are exogenous processes going on. You don't see it really. So exogenous means there are no, from the decision unit, that's the decision unit, there are no decision going into the price and the demand. So the price and demand is unchanged by the decision. It's pure exogenous, it runs. Yeah, you immediately see structure here a little bit on this exogeneity, endogeneity dimension, that's important. Then the charge, that's how much the energy is fueled, goes into, the price is observed, and the demand is observed. Then the battery decides on loading or unloading. That could be a minus loading and plus loading, unloading, however. The guys who wanted to see that modeled it like that because there's some asymmetry built in. Price of loading and unloading is different, that's why it's not completely symmetric. So then this is unloading, loading. Then what's going on here, that's a huge calculation of the profits, right? So that could usually, you would put that in a box. I haven't done it here. So that would be, the whole profit thing here would be here completely in a box, and then you would really have only the battery, profit, charge, price, demand, and then here as well. So what is that? That's the charge. So that's the specification of the process, how the charge is evolving, right? So you see here also all the ingredients we can model with open games. So you could have, I will show it later with more systematically. So you could have really a decision, you could have pure computation, you could have parameter, right? And state transitions. So then something very bad happens here, namely all these things. So we have kind of specified the calculation as well here. So this has nothing to do with the game, but it's just you specify the calculation, the numerical algorithm itself here as well. So that's not an open game, that's just a hack. So then what you do, so we did it like that, so you just press on it here, and then some calculation is going on. Oops. Yeah. So you calculate it, and then you plot it, and then you see the optimal decision here. So that's the policy function. It tells how the battery is optimally behaving. So it optimizes if you look at that. So the battery is optimizing the profit. So that's the essential part. So for this little wiggle, we need all this machinery because that's the core of economics, that this battery is anticipating the future. So you see this is bending down, so time goes downwards. This is the future, and the future is taken into account, and here the profit, how the profit in that period and the profit from the expected period is calculated, and then this is here back taken into account by this decision maker, right? So that's anticipative behavior, that's the core essence of economic modeling, right? So you see that's all there is on the user interface. The problem here is that this is hard-coded, right? So that means the full-blown compiler is not working right now. So the whole enchilada of a compiler would be something like that. So you see, so you have here the algebra or the visual, the string diagrams would be the game, the decision, whatever it is, right? So these kind of things. Then this is translated by the compiler into the algebraic expression. The algebraic expression is then used by the engine to do something, analyze the game itself, solve it, simulate it, or here I just sketched it you step through it like in this similar way as Alex showed for the pigeon. It's just a step up. What is nice here, because all of it here is compositional, so that's really the power of composition of the equilibria is you see here. You get more or less for free a description, a calculation of the incentive structure. That's powerful, right? Here, at each, you see, if that would be a huge tree of the decisions, then you could go through, have the focus, for example, on the node where this guy has to decide, and then the engine would tell you, oh, you go to the left because it pays off to go to the left, and taking into account that the other would down the road 3 steps later go to the right, and that would reduce your utility. So that's a very nasty calculation even for 2-player games and whatever, if you do it by hand. So that's exactly where compositionality of open games on the level of equilibrium pays off, right?
How does the engine do in terms of complexity?
The engine is right now.
The engine mostly hasn't been written yet.
Yeah. So the stages we have some. Jules has some version of the compiler. Then a big problem was that these types of the open games do not unify properly. Mirzan, as a PhD student from Alexanderplatz, has hammered out now after quite some time a version which can unify the types, and then this can be composed, and then the next step would be, first stepping through stuff, simulating stuff, and then and then starting to connect numerics. So we have some numerics going on there, a library, but that is a big issue. So compositional numerics is a wide open field. So it's similar to the guys, for example, if you want to know what the problems are, the guys from probabilistic programming language, they have the same problem. So they have this way to compose statistical games, models, and then there's this function infer. So it does the inference algorithm. And the inference algorithm needs to compose for all the composites of your statistical model all kinds of numerical methods. Simulation, Monte Carlo, integration, functional approximation. That's a big beast of a problem, how to do it.
Just want to refine that comment and say that inference is one possibility, but checking is another one. That is potentially easier.
Yeah. So what one can do, what is always a possibility, is to do the simulation very, very efficient. If we have now the clusters at our disposal, simulation with Monte Carlo integration and optimization by, let's say, simulated annealing kind of stuff is always one way. Of course, it's not very efficient, or not at all efficient usually, especially because we have the structure of the problem, right? So these Monte Carlo simulation-based methods throw away all the information you have on the structure of the problem, and that's what we would like to put in. Okay. Now, how is this system working? So this, what you see now here, so this thing's the UI here. So you see it's running on the browser. So there is GitHub. Then it compiles Jenkins server. The Jenkins server on the RVS compiles it into on the RVS, right? on Amazon Cloud. You can also compile it locally, and then you have here the UI in the browser, which is a GHCGS. It's a Haskell code compiling down to JavaScript, and this is then the client, which is then running on the Amazon Cloud, or connects to the Amazon Cloud. Also by serialization, we need this JSON problem as well in one way or another.
So this thing's almost all written in Haskell.
Yes.
With a little bit of inline JavaScript.
Yes. So there.
And a little bit of inline C and numerics.
Exactly. And then you can also run it locally for development and so on. So that's the situation. The next step is here. So that's the start really to unify this compiler and the engine, and then put that to the UI, and then you can start really modeling using the put numerics on it and so on. Voila, thanks.
So these string diagrams, you can move the nodes arbitrarily, right?
Yeah.
Which assumes a compact closed structure, but you guys only have clubs and not caps. So how do you,
There was so at some point this was in a loop calling a function that I wrote to check consistency, but it was very slow because I the program.
oh, okay, right.
So I think at the moment this relies on a human to not do stupid things.
Yeah.
But
So
I mean, at the moment there's no semantics in the software.
No, no.
When
But I'm just talking about just the drawing pack.
Yeah.
Because that's
I developed an algorithm to stepwise, edit-wise check the consistency of this thing. It's just not running at the moment.
So that's part of the no intelligence to the UI.
We assume a non-hostile direction.
Yeah, so and of course the goal would be here, just to sum it up, the whole point of modularity or compositionality would be here to have some prefabricated modules, right? It could be options or whatever. And for example, the guys who are doing now social games, they pile up companies, groups of people up to democracies, right? So then you would have here democracy, anarchy for Neil, and all kinds of things, right? And you, yeah. So you will be in charge of developing that module then. Yeah, thanks.
Wrap it up. Thanks again.